Hey everyone, welcome back to Code Streak Daily. In today's video, we will be solving an interesting problem. It's the max distance between same elements. So it's an easy level problem. Now let's see the problem description here. Given an array ARR with repeated elements, okay, the task is to find the maximum distance between two occurrences of an element. There's a note given here. You may assume that every input array has repetitions. Okay, let's see the example here. There is an array which contains elements 1, 1, 2, 2, 2, and 1. The output is 5. Let's see the explanation here. Distance for 1 is 5 minus 0 equals to 5. Distance for 2 is 4 minus 2 equals to 2. So max distance is 5. So let me count the elements 1, 2, 3, 4, 5, 6. Okay, there are 6 elements here, and I think these are the indices. So the fifth index, as the array index starts from 0, I assume that this is the 0th index and this is the 5th index. So 5 minus 0 equals to 5, and when it comes to 2, this is the 4th index and this is the 0, 1 and second index. So 4 minus 2 equals 2, so max distance is 5. And let me explore the second example here. There's an array with some elements and the output is 10. The maximum distance for 2 is 11 minus 1 equals to 10. So I assume there are, as the maximum number is given as 11, so there are 12 elements here, and this is the 11th index as index starts from 0. So 11 minus 1 equals to 10, and for maximum distance for 1 is 4 minus 2. So 0, 1, 2, 3, and 4. 4 minus 2 equals 2, and maximum distance for 4 is 10 minus 5 equals to 5. So 10 minus 5 equals to 5. So maximum distance is 10. So the task is simple. We are given an array with repeated elements, and we need to find the maximum distance between the first and last occurrence of any element in the array. So the expected time complexity should be order of n, and the space should be order of n as well. Now to solve this problem, let's use the dictionary for index tracking. So because we can use dictionary to keep track of the first occurrence of each element, and as we traverse the array, we can encounter an element that we have already seen. Then we will calculate the distance between the current index and its first occurrence, and we can update the maximum distance accordingly, right? Okay, now let's dive into solving of this problem. Okay, now I am writing this code, and I'm taking a dictionary to store the first occurrence of the element. So I'm taking like index map. It's an empty dictionary, and I'm also taking the maximum distance equals to 0. So now we have to traverse the array for I in range of length of the array. If array of I in index underscore map, if the element is in the dictionary already, then we have to calculate the distance. So max underscore distance equals to, we have to take the maximum value, right? Maximum of max underscore distance, and we are taking the values of the index of the next occurrence of the element, right? So I minus index underscore map of array of I. So this is how we get the index of the next occurrence of the element. If the element is already in the index map, we will use that. If not, we have to store the first occurrence of the element. So index underscore map of ARR of I equals to I. So this is how we store the index value of the new element in the dictionary. Then I am going to return maximum underscore distance. So let us see whether this works or not. Okay, our output matches with the expected output. Let me submit the code and see if all the test cases will be passed or not. Yeah, okay. All the test cases are passed. There are 1110 test cases and we have a accuracy of 100%. The total time taken is 0.49 seconds only. So this is how we will solve this problem. Let me take you through the code again. We created an empty dictionary called index underscore map that will store the first occurrence of each element in the array. Next, we have initialized the max underscore distance with a 0, which will store the maximum distance we find. And we have to loop through the array. We check if the current element already exists in the index underscore map. If it does, we have to calculate the distance between the current index and the stored index. And then we have to update the maximum index. If the element is not been encountered before, we have to store its index in the dictionary. Okay, so coming to the time complexity, we have iterated through the array only once, which will give us a time complexity of order of n, where n is the size of the array. And coming to the space complexity, we are using a dictionary to store the indices, right? So which also results in space complexity of order of n. And that's how we solve the problem of finding the maximum distance between two occurrences of an element in the array. So if you enjoyed this video explanation and if you want to keep your streak daily in both Geeks for Geeks and as well as lead code, do subscribe our channel and hit the like. And if you have any queries, please do put them in the comment and keep code streaking daily.